My name is Cristián. I like Python, like you all, I hope. But I also embrace the idea of liking other languages. How many C programmers do we have in the room today? Can you raise your hand? C programmers, actively C programmers. Yeah, I knew. Okay. So this talk is an advanced talk, as you saw in the program, and the reason of that is because every time that I was putting these talks into intermediate, a lot of Python developers would arrive in here without any knowledge of C, and they were very scared about the things that I was explaining. But don't worry, at least all the material will be online afterwards. I will share on Discord, so you can reproduce the examples and everything and try it out yourself. So if you want to connect with me, ask me any question, that's my social media or my website, you can find me there, whatever. So I started with the talks on this topic because I had the feeling that every time that you were mentioning Python internals, people got scared. They thought there was a very obscure thing that nobody understood, so it was very difficult to understand, right? So with that, the motivation of this talk, as I said, is twofold. The first one is for you to understand how things work. I am personally very inclined into trying to understand how a system works. Like, I'm pretty sure many people here, when you were a kid, you were like destroying some toys and see how things were working inside. Because I have the feeling that this is very useful for you to understand the actual thing you're using. But the second one is to lower the barrier. I just want you all not to be afraid of Python internals, just to understand a little bit better, and maybe having enough tools to try it yourself. So most of you, as I said, usually treat Python as a black box or something that you know what is in the middle, something does, but the only thing you know is that you need to write some Python, right? So because it's an advanced talk, I want to see what is the audience level currently. So don't worry, I will ask you to raise your hands in some part of the talk, but now I would like for you to shout a few things. So who is using Python 3.15 already? No? No package maintainer? Thank you very much, Hugo. So I just compiled this from CPython, and I wanted to try something with you. So, okay, let's start easy. Declaring a list. Everything is fine, right? All good? Yes? Okay. How do we add the number 1 to the list? You can shout. Perfect. How can I add an item twice to a list? Right? How can you? You need to read the documentation. Come on, this is Python. It's 3.15 is coming to you all. You need to have this thing in production. How can you add an element to the beginning of a list? You need to just no. That's. It's just a penalty otherwise. So come on. I mean, this is an advanced talk, people. Like I was expecting more. Okay, let's do something easy. So, do you know how to, I don't know, have a loop that iterates over the first 10 numbers and can give you the even numbers? With what? With the range, and then you use the? Which is the loop name? Is a while or is? Yeah, but we're in Italy. So it needs to be the per loop, right? Re nell'intervallo. And then we need to check. And then finally we do the stamp, but everyone, of course, no. Right? So this is, of course, if you're in a different country, you need to code in different language. Okay, so, well, you're not so advanced that I was expecting. I'm sorry, but anyway, let's try to fix that. No, it's completely fine. So before understanding how this thing could happen, we need to understand programming languages in general. I will not take a lot of time for this introduction, but if you go to Wikipedia, maybe you already saw that there's a huge list of languages there. You can get crazy by trying to understand most of them. But I want to focus on the C programming language. I learned how to code in C. I don't know if that was a good thing or bad thing, but it was challenging. I didn't even touch code before, but I learned in C. The long story is that Ken Thompson at some point was trying to write a compiler for Fortran. He said, no, this is too difficult, and decided to use BCPL and then mix it with a little bit of Smalgold and created a language called B. Very original, right? And then Dennis Ritchie came and I said, well, maybe we can improve this thing, add a few types extra, whatever, put some assembly code on top of it, because everyone knows assembly as well. And then they call it the new B language. So they said, maybe, wait, we call it C. And that's the story of C. C is very crucial for everything, right? I mean, if you want to summarize it with one slide, C really runs the world. Everything was writing. I mean, Git, the Linux kernel, Windows-based system, whatever you name it, has some C components, right? So, but we're here talking about Python, not C, yet. Who recognizes this code? Can you raise your hand if you recognize it? I will not ask you, don't worry, I will not put you on the spot. Because we talk about programming languages, we talk about inspiration and evolution of programming language. This is ABC. This is the predecessor of Python that Guido took into it and tried to build Python. So if you see like the for loop in the middle, you kind of like feel the Python in it, right? You have this for whatever in document, so it's very typical. So Python was not like from the suddenly like appearing and popping up from nothing, right? There was a predecessor. So there have always been previous programming languages that you used to fix everything inside, right? So let's talk about the Python implementation there. But there is a detail. Which one? I always like to show this screenshot. Which is the Python you use? Can you recognize it? No? Well, maybe you saw that some of them has the greater than like 5 times or 4 times. Well, I hope this is not new for you, but these are the languages that you have there. So first you have MicroPython, then PyPy, the version written in Python. Very weird, I know. The implementation written in Java, the implementation written in Rust, in C#, and the last one is the vanilla Python of everything that you are using. But it was very difficult to understand, right? So Python is kind of this kind of weird thing. So we will focus on the standard implementation, which is the Python that is written in C, right? So if you go to GitHub and check it out, you see that there is a 35.8% of the Python that is written in C, and this is because most of the building blocks of the Python programming language, the C implementation, are in C. But what about the ecosystem? You have heard a lot about this thing. So if you check out Pydantic, for example, we had a talk the other day, they have 40% Rust, 59% Python, okay? PyTorch, maybe you're also familiar, they have a huge portion of C++ because Torch is written in C++. Then you have DuckDB, in case you're familiar with this SQL database management system. It has a lot of C++ as well. UV is also might be very popular right now, so a lot of Rust there. So most of the packages that we use on normal days mix many programming languages, right? So that's why I believe that it is still interesting for you to learn or at least to understand the C implementation of Python and try to go deep. But for that, we need to learn a little bit of C. So Python and C, very quickly, I will show you this Python code. Everyone should read it without any issue, I hope. So I tried to force there the print in order to look more similar to the C implementation. You have there roughly an equivalent. It's not exactly the same, so the C purists, please don't worry. I understand that, but it's just similar so you can get an idea. Not very complicated, right? I expect you feel the same thing. And if we add type hints, for example, to Python, I don't know. I mean, if you believe that one is more complicated than the other one can argue, but as you see, the C implementation there is not so critically like complex and everything. So you kind of get an idea. So a few details of the language. I don't want to bore you with this. So in C, well, back then it was a high-level programming languages because you could, not program in assembly. There are not only one int. There are many types depending on the precision and the number you need. There are, of course, 2 decimal types in case you need single, double precision, which is very related to CPU architecture, but we will not go there. There is also this concept that doesn't exist in Python that you can declare variables without initializing. So in C, you can do the int variable, and then you have the variable declare with an undefined value. You don't need to have a value or a non-type at the beginning because that is initializing the variable. Memory management, which is some of the critical aspect of the unsafe of the language that many people are saying, oh my God, we need to do memory allocation our own self, and many other programming languages are solving like Rust. So in C, it's a bit more complicated. You can create maybe an array of integers at the first line there, or you can do it allocating memory and allow, like item by item, putting them there. Of course, you cannot mix types there because it's, well, you kind of bypass it, but literally you cannot simply with the native data types. And also you need to free the memory. So this is the caveat that people start to say, oh my God, I need to worry all this thing, but it's not so crazy. The structs in C are something that are very similar to a data class. I guess that you're all familiar with data classes, so it shouldn't be so strange to have this thing around. And Pointers are also something that might be very tricky for you. I know that we are going a little bit fast, but I want for you to at least to get the general overview, and then you can check that out later on. In a nutshell, pointers for you to understand is that you have a variable, so you have a value associated with something that is in your memory. In that case, the memory address, for example, is 1000, just an example. But there's also this concept of pointers that you can point where something else is. In this case, we're pointing with the other memories. So as you can see there, the value of P is the 1000, which is the memory address of the next variable. Sounds a bit tricky, but I promise you, besides that, it's not so complicated. Let's do a little example. I know you will maybe will be unable to reply, but let's just do it for the sake of things. So if we have a number 42, a variable int, and then we have a pointer pointing to that address, then we know that B also will be 42. Easy, because it's the same as the other example. Then we create a copy of A, and then we do another variable that has the value of the pointer of B. So these are the values that we have currently with the current configuration. Why pointers are seen as difficult is because the arithmetics between them, when changing things, can be complicated if you don't remember all the details of the things you have, where things are pointing, right? So if we do these two small changes, at least you can say that, okay, the pointer B will have now a value of 10, but then you start to think, oh, but wait, B is pointing the reference of A, so it also will change A. And then you are changing C as well. So this is how we ended up thinking. So this is why at least pointer arithmetic, I hope this was not so confusing, but it can be tricky because you need to keep track of where you have your things, the memory allocations, if you have pointers, where they're pointing at. Okay, this is easy one. This is the most simple C program that you can find, of course. If you had to have a hello world kind of thing, you need to write a main. For using printf, you need to do this include, the standard input output, and then also you need to compile. That's one of the biggest difference as well. You need to compile this language in two ways. You can have the first one kind of like without specifying many things with GCC in this case, or specify the name of the binary and you execute it. So yeah, that's it. You learn C, and I am really proud that now you will be able to understand. But as you see in the bar on the bottom, we are not yet done. So let's look inside. I will not spend a lot of time on this, so we will close our Python 3.15, and we will do something very weird. If you're not familiar with GDB, don't worry about it. It's just something that you use to look inside binaries. So here, I told you that you need to have the main function. So for example, we can do something very simple and try to say, oh, let's break when we find the main function. Okay, we need to download some stuff. There we have it. That's the main function of Python, which is calling another main function called py bytes main. So if we continue, we see that that main function has another main function called pymain main. We can continue here for like 3 times, but I would not like to continue, but at least I would like for you to see that you have started to see some like notions of variables written with py something. So maybe let's do a break with that one. So maybe you can see something else that I wanted to show you. Yes. So you see that there are also some other variables, py status, whatever. So there's like apparently all these variables are py something within the C implementation of Python, right? So I know, as I said, this was very weird and strange. If you have questions about how this thing is there, then ask your nearest core developer so they can reply why there are so many mains there. But that's not my discovery in this talk. So now the idea in the remaining like I have more time, so I'm going to slow down. For you is for us to rediscover Python a little bit through C. Yeah, how the Python works, but okay, we need to correct how CPython works because I will not talk about the other implementations. In a nutshell, this is the most simple approach that you can understand what happens between your Python code and what is being executed. So there's a decoding first, depending on the encoding of the file. There's a tokenization part when you start to split your code into bits. Then you are parsing to try to understand those things that you cut. And there is an AST, an abstract syntax tree. It sounds more complicated than it is. I saw some people join there, so don't worry about it. This is the only slide about this. Then you have this structure of where to resolve in which order, right? And then you have the final compiling step for the virtual machine of Python. So you have a virtual machine that have instruction one by one, right? Simple. Who here likes that now Python is faster with the faster Python project, right? Well, because of that, because you need to start doing optimization in your code, this is kind of a different now. So in this little step there is a lot of things happening now. There are some optimizations. Now all this bytecode that I told you, there's some, they are split further on in some micro operations, and then when they have all the micro operations, they remove the ones that are very redundant, and then after they remove them, they detect the hot codes sections, and they start, so everything is a bit messy there. But for that, I am not an expert in that topic. I really recommend you for you to watch Brand Butcher talks from PyCon US from last year and this year. Very cool talks, so I totally recommend it. So for the code, I hope that at least you knew that Python is on GitHub. You can find it under Python/CPython, the standard implementation. And inside there are many directories, and I will not go into a lot of details of what do you have to find inside, but the most interesting thing for you to understand is that you do have some splitting between the modules, which is the standard library written in C, the objects, so for example, a list, a dictionary, a tuple, a set, those things are written in C, because we thought already that the building blocks are written in C. And then you have the runtime with everything else, right? So how does the abstraction work? Now we'll start to look into details of the CPython. So if you have some coffee, please sip some coffee now, because that's the part that might become a little bit denser. So everything in Python, well, most of things are encapsulated into a PyObject. But you already saw that the struct in C, it's kind of like a data class, so it's something, you need to fill with stuff, right? So PyObject, the building block of everything inside C. This is the definition of the object, which sounds or reads very complicated. But in a nutshell, it's only some workarounds, some compatibility things with compilers, because we love to run Python everywhere, but to run Python everywhere, we need to be compatible with many compilers in Mac OS, in Linux, in Windows, and now the new architectures. But for the case of Linux, which is what I am using here, this will be the simplified version after resolving all those things. Pretty simple, right? Yes? The thing is, then you see there that there is another thing called PyType object. Well, this is also a building block of CPython, which is the type information of this object. So it's called optype. You saw a pointer there. Well, that's pointing somewhere when you start to implement it. So I hope you are connecting the dots at least with what we saw before. And if we look inside this, it's a bit overwhelming, right? So this is what is inside this type object structure. But it's a structure full of different cases and things you can use depending on the type you have, because we love to write A equals 2, and then you get an integer, or B equal hello, and then you get a string, right? But to have this kind of like not worrying about declaring the type, you need to have something generic enough in order for you to be able to handle it, right? So you have all those things, but as I said, it looks complicated, but it makes sense. This is the simplest analogy that I could find in order for you to understand this type object or the PyObject. If you have this piece of furniture, and you put it in your room, what do you fill it with? Maybe clothes, I don't know, some old hats or whatever. But if you put it in your office, then you will put some office supplies, right? Like, some pens, whatever. The idea of PyObject is the same. You fill it with whatever you are using. So in a nutshell, that's it. If you want to have an integer, you will have a lot of attribute inside that depends on for integers, but the one for strings are not in use, right? So you fill it with whatever you need, and then you manage to have this amazing encapsulated object. So now everyone is thinking that Python is easier, right? Who thinks Python is easier? Don't be afraid. I will not call you out. Don't worry. Okay. So now we'll do a little experiment. Who is familiar with this Python code? I will not ask you, don't worry. Just raise your hand if you understand the code. You don't need to say it. Maybe you can say it to the person next to me. Of course, it's a lambda function. Keep it up. Keep it up. Now, who is familiar with this syntax? This is valid Python code. Oh, there was a overwhelming hands going down. This is just initializing a list of all these letters. Okay, keep it up. Who understands this code? Take your time, read it. Keep your hands up, because we are proud of, I think we have like 5 people remaining in the room. Okay? Who understands this code? Yes, I know, because you know this, and other people. Yeah, this is the Quine. So if you execute the code, check it out after the talk. Who understands this code? Okay. Oh, more hands going up. Oh, good. And this one? Who is brave enough, not you, to shout what this the code does? Or what it does? It's clearly, you can see clearly there, that is checking if a number is a power of 2. I am very disappointed again that you cannot see everything. You can try it out, I'm not lying, but you can try it maybe after the talk. And what about this code? No, I'm just kidding. This is Python, which is a different Python. It's for code golfing, but if you're interested in this, you can check it out. So all languages can be hard and easy. Please do not use this argument, at least after this talk of, yeah, no, I prefer to use things in Python because everything is so easy. Well, you saw already, things can be complicated. Maybe you will not find that thing too often, but it's possible that you will find maybe your new, I don't know, employee in your company will submit a patch doing these crazy things, and you will need to be able to understand because you're a Python expert, right? We all are, I hope. Here, I'm not, but it's fine. So yeah, as I said, this sounds complicated, but I hope you don't worry, because the C API, in my opinion, the implementation is very, very simple. Inside, you have a lot of functions in C that helps you to navigate all the types that we were looking at. So we talked already, PyObject, a big object that can hold different things, a container with things. But if you want to check and build stuff, for example, there you can transform a C string into a PyObject that will be futurely a string with PyUnicode from string. Then you can get the len function from C with the getLen method as well. For lists, for example, you have that. You can build the same string, create a new list, and append in the value. So you see that, I mean, now you know a few things, so you can understand. But the idea of the C API is to be simple. The same reason that we have this PyObject with many things, we have also very convenient functions to detect, is this a list? Is this a dictionary? Is this a tuple, right? Very simple thing. And even further, which is something that I really love, is that all these functions, I guess many here knows the function glove, because you have using for, of course, not the best, most efficient thing, but you know it. So to list some files, this is the way that you can parse all the arguments of your functions. There are this very amazing function called pyarg, parse, tuple, and keywords. Yeah, long name, but it's very useful. So you can call it already, and automatically it will parse everything you have in your Python function, and it will abstract everything to C. Very convenient. So sound more reasonable, I hope, from all the C abstraction that we were saying before. You have like very ad hoc methods and stuff, so I hope you are more convinced. So for example, we were playing around with the append code before. So if you want to check the append now, the proper implementation is this one in internal CPython. And then you have there's this pylist, append, take, reference kind of thing, which in a nutshell, I know this sounds like, wow, very many things happening, but it's only making sure the size is correct, resizing your lists by 1, and then adding a new item there. The reason that I left this commented code there is because this is how it used to be. Pylist set item makes a lot of sense if you ask me. But with all the things about now no GIL that everyone is so happy about it, this is the way of writing that line of code, because you need to have an atomic operation not to mess up with all the threads happening. So see, we are getting a lot of performance things, which is an amazing thing, but this needs to complicate a bit the implementation. At least it's one line, so that's a good thing. So most of the details of the C API are in the documentation. Please, please, please don't be afraid of checking it out. I know that maybe you will not use it in your everyday, but just go there and check it out, because at some point maybe you will be debugging some Python code for some reason and you end up with CPython code and say, whoa, what is this? You will get an idea of what is happening there. So for talking about the object lifecycle, I prepared only 219 slides, but the idea of this is objects, this PyObject that we talk, they live in this control reference counting kind of like approach. Meaning it's like if you have an object, you use it once, then it's one reference. You use another one, 2 reference. But then you stop using it in one place, you decrease 1, and then when the thing decreases until 0, the object is destroyed. So as I said, if object has no reference, it's garbage collected. That's why we don't need to use. That's why we don't need to use anything like that. Yeah. So you need to increase and decrease the thing accordingly. We will keep the other 218 slides because this is a very dense topic. I know if you start to look inside, there's a lot of details of when to decrease because you need to do some checks and everything. But I just wanted for you to be aware because since before we were talking about this memory allocation and freeing up memory, you need to know more or less like how Python objects are being built or handled out. So is this usable in real life? And the answer is yes. So before we were describing some modules that maybe you know, and for example, I work in a project that is literally exposing some huge code database in C++ to Python. And for that, we need to understand how to create extensions of Python in C. I think that I will use a couple of extra minutes for this explanation, but we will stay in time. So an extension in C can be written. This is the most simple one that I could have. You can check it out later because the code will be in the repo that I will show at the end. This is just a function that has hello, building some string for Python, declaring all the functions of your new module, and then struct, you remember, just a box that we need to fill with some stuff, some detail for creating a module called PyCon It, and then we decide, please create a module. Everything using the C API. So what you get from this, when you compile it, is that you can get this module with the function hello, and then you head a string. So this is kind of the easy approach that many people use when you have to optimize a little bit of bottleneck of your code, that you want it to be more efficient and stuff. If you like Rust, in my opinion, I think the developers of PyO3 did a very good job because the API is very simple. Who here programmed in Rust, by the way, is aware of Rust? Okay, cool. Professionally. I knew. Okay, so you can create similar things here, and it's also amazing in Rust. It's not only C and Rust. There are many languages that expose this thing to create modules with Python. So in a real project, as I told you before, I work on this project. You maybe don't know it. I will not bore you about it. I promise you this is the only slide that I have, which is moving a huge C++ framework that is older than Python to Python, right? So in case you want to check it, maybe some of you thought PyQt. No, that's a different story. It's PySide. So if you want to check it out, you can do it. But this exactly the same idea. If you really learn everything that I have been telling you here, you are able to really grab any C project or C++ code and try to do it there. But exposing these projects is not very easy. And I show you all these lines of code to just do one method called hello, right? So it's very cumbersome. But you're not alone because there is a lot of tools out there, binding generators like PyO3 that we just saw, that can help you on these things. I will not go into detail. This is a brief summary of C and C++ support binding generators. The one in green there is the one that I work with, so it's compiled with PyPy and CPython. And the one we saw in Rust is PyO3. But maybe you're familiar with PyBind11 and CFFFI or Boost Python even, right? So these things simplify the whole process for you to kind of get this kind of things. So I hope that at least now you have experienced Python differently, hopefully. And you have the tools now at least to keep learning without being afraid. So I hope maybe also you can make the changes that the language needs. And that will be it from my side. So thank you very much for your attention.
So thank you very much. If the phone doesn't trick me this time, we have no question. So maybe I will be going to pick someone.
That's perfect, because if no question, it means that everything was very clear. So I'm really happy about the outcome of my talk.
Maybe we're going to pick someone from the public.
If you're interested on the Italian Python code, by the way, everything will be in the repo. I think that I didn't push the patch there, but it's simpler than you think. So I really hope you can give it a try. And it's open source, so you can use it and do a lightning talk maybe today, tomorrow, or maybe submit a talk to another conference.
Oh, okay, we have a question there. I'm going to... Sorry, can you... Oh, okay.
So, thank you for the presentation, first of all. It was very nice. This is maybe more of a curiosity. So you focused on CPython. And there is some debate, as far as I'm aware, on how much the C API should be coupled to CPython and how much it should be implementation agnostic. So what's your thought on this?
Yeah, I mean, my opinion is that there should be something. I also gave a talk about HPy at some point and the stable API. I know this word sounds weird, but bear with me. So yeah, I also believe that, I mean, I don't know if the best solution is to decouple completely, but the problem that we have the C API at the moment, at least the people maintaining modules with C or a C++ extension, is that things change, things break, and if you want to use new API, you cannot, as long as you use the stable API. Why this stable API thing is a thing is because I can generate one wheel for Linux from Python 3.6, for example, and it will be compatible forever. That's the stable API. You have seen many projects, for example, NumPy. NumPy does not do that. So you have like wheels for Python 3.7, 3.8, 3.9. So with this approach, you have one wheel, which is, in my opinion, the best approach to have one package to serve everything. But I will try to maybe think that, maybe you have heard about the Wheel Next project. So they are also trying to implement some kind of like better wheeled infrastructure that maybe this could be tied. It's a shame that Hugo left because maybe he will have the answer as a core developer. But I believe that at some point we will need to reach that. Maybe use HPy if people like to jump into it, but I don't know. But now it's very tricky, and I hope that we find a solution, but I don't have an answer for what would be the best.
Yeah, thank you, thank you.
You're welcome.
Okay, so maybe we can pick another one. Okay.
My question is, I've come across the C-types module.
Yes.
And I found it very useful for bringing bringing C libraries to Python. And do you have any downside you would like to share against the other approach, like to build the C
Yeah, I mean,
extension?
It's a very simple, and I think that is a very useful way for you to get started on this thing, but you will start to find issues when you want to have deeper control of your structures and objects. So for example, I really don't know if you can with C-type, you can correct me if I'm wrong, but I think that you cannot kind of define the ownership of objects. For example, you have an object in C++ or C, and then I wanted to pass it to Python. Is there a way of saying like this object now belongs to Python, so I don't care about the C implementation, or the other way around? Which sounds complicated, but it's a very usual problem that at least I, as a maintainer, find in the package that I maintain. So all these low-level configuration for initial things, like, oh, I want to optimize this a little bit, a few variables, very good. But when you need to do more advanced things, or let's say you want to build the next PyTorch, I think that C-type will not scale because there are too many details that you need to handle that C-type does not cover. But yeah. Good.
So thank you very much. You can follow up with questions after the talk. Thank you again.
Thank you.